Now we are seeing a problem from the topic principal stresses and strains. Let us see the problem. At a point within a body is subjected to two stresses in two mutual perpendicular directions, and the stresses, the values of stresses are 80 Newton per mm square, that is tensile, and 40 Newton per mm square, that is also tensile. Each of the above stress is accompanied by a shear stress of 60 Newton per mm square. So there is a shear stress also. Determine the normal stress and shear stress, normal stress, comma, shear stress and resultant stress on an oblique plane inclined at an angle of 45 degrees with the axis of minor tensile stress. So here at a point in a body, at a point, the point is acted upon by two stresses. Those two stresses are given like tensile in nature, and uh, and those values are given, and those are acting in two mutual perpendicular directions, and the values are given 80 Newton per mm square and 40 Newton per mm square, both are tensile given, and we are taking that 80 Newton per mm square like in x direction and 40 in y direction, and here and these stresses, these tensile stresses are also accompanied by a shear stress, and the value of shear stress is 60 Newton per mm square. So here if you take if you just represent here, so these stresses, these two stresses acting in these two directions, so it is accompanied with a shear stress. So we'll get shear stress on this all four sides or two directions. So there is a given here accompanied by these two stresses is accompanied by the shear stress means, so the shear stress will be on the four faces, means when if a shear stress act in one plane, it is a complementary shear stress will be developed anyway. So anyway, it is value is given 60 Newton per mm square, 60 Newton per mm square given. So in this case, is asking to find out normal stress, shear stress, and the resultant stress on an oblique plane, which is making an angle of 45 degrees with the axis of minor tensile stress. So here is given two values of tensile stresses 80 and 40. So we are taking and this will 80 will become major tensile stress, and we are taking that in x direction, and 40, that is minor in y direction. So this is the axis representing the minor principal stress, and oblique plane is making an angle of 45 degrees with this minor principal stress. So with this minor principal stress, this oblique plane is making 45 degrees. So here to calculate normal and shear stresses on this oblique plane, we have some formulas, and those are in terms of sigma x, sigma y, and in terms of theta also. But the theta is measured, or we have calculated in the theory part, that is measured uh, with respect to the cross section of the member, or the direction, in the direction cross section with respect to cross section of the member, or in this direction. So if you see, if this is theta, so this is also theta. Why? Because these two are alternate angles. So if this is 45 means this is also 45, and this is the value we require, the actual value of theta we require, or we are supposed to substitute in the formulas. So this is also 45, and this is the required angle theta. So I told these two are alternate angles. So if this is 45, this is also 45, and when you measure the angle from this side, that is a required angle theta, and that will be 45 here. So here we can write simply major tensile stress sigma x is 80, minor tensile stress sigma y 40, shear stress is 60 Newton per mm square given, and angle of the oblique plane with the axis of minor tensile stress is again 45, and that will become theta 45 degrees. So here to find out normal and shear stresses on this oblique plane, we have formulas, and the normal stress formula is given by sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau sin 2 theta, and the shear stress formula is given by sigma x minus sigma y by 2 sin 2 theta minus tau into cos 2 theta. So friends, for the derivation of this normal stress formula and this shear stress formula, please refer my previous video on principal stresses and strains, that is case 4 video. So anyway, here we have to find out normal and shear stresses. First of all, if you see the normal stress, so this is the formula we have seen. So here just substitute this values we have taken sigma x, sigma y, and substitute this here. So sigma x we have taken 80 and sigma y 40 by 2, and sigma x 80 40 80 minus 40 by 2, and theta value 45. So it is cos 2 theta, 2 into 45 plus tau is 60 given, and sine 2 into theta value is 45. So when you simplify here, this will be 60 plus this will be 20, and cos 90. So cos 90 will be 0. So 20 into 0 plus 60 into sine 90 is 1. So 60 into 1. So when you simplify this, this is a 0, the middle term. So 60 plus 60 will get 120. So the normal stress on this oblique plane will be 120 Newton per mm square. And next we have to find out shear stress or tangential stress on the oblique plane. So I told the shear stress on the any oblique plane is given by the formula sigma x minus sigma y by 2 sine 2 theta minus tau into cos 2 theta. So sigma x given 80 minus sigma y 40 by 2 sine 2 into 45, and minus tau is given 60. So cos 2 into 45, and when you simplify, so this term will be 20. So 80 minus 40, 40 by 2 is 20. This is sine 90, that's value is 1, and 60 into cos 90 value is 0. So this term is 0, and the remaining is this one only. So that is 20 Newton per mm square. So the tangential or shear stress on the oblique plane is 20 Newton per mm square. So this is the normal stress, that is we got 120, and tangential stress we got 20. So this is a normal stress, and there is tangential stress on the oblique plane. And here is asking also to find out resultant stress on this oblique plane. So just when you represent, this is a normal stress and this is a shear stress, and this will be the resultant between this normal and shear stress. And from this diagram, just you can write the formula for resultant stress as sigma r is equals to under root of sigma n square plus sigma t square. So just when you just transfer the sigma t here, so this is the sigma n and this is the sigma t, and both are perpendicular, and this will be the hypotenuse if you just assume like that. So anyway, just simply you can write sigma r is equals to under root of sigma n square plus sigma t square. So sigma n we got normal stress 120, and the shear stress is 20 we got here. So when you simplify this, the resultant stress on this oblique plane, we are getting it as 121.655 Newton per mm square. So this is the way to solve this kind of question. So for more videos, please subscribe and activate bell symbol, and also please share my videos with your friends. Thanks for watching.